A very good morning to all of you. Again we are here to discuss one analog multiplexing technique, that is frequency division multiplexing. In FDM, that is frequency division multiplexing, all users use same common channel at the same time, but they are allotted different frequency to prevent any kind of signal interference. So, this statement can be viewed in this graphical approach. Here we are having a frequency axis and here we are having a time axis. In this we are having different users, user 1, 2, 3, 4, and these users are allotted different frequency bands. I mean to say that from here to here we are having a bifurcation in frequencies, so that these signals can be easily multiplexed over the communicating channel, because the link which we are having right now is having a high bandwidth. So, that bandwidth of frequency is divided into different multiple users in order to communicate over the channel. So, this frequency is converted into different frequencies and these users are allotted different frequency bands to communicate over the medium. Or we can say that it is an analog technique that can be applied when the bandwidth of a link is greater than the combined bandwidth of the signals to be transmitted. So, this is the reason only why we are allotting different frequencies to the user, because the bandwidth of the communicating link is greater than the combined bandwidth of the signals, right. So, it becomes very difficult to send different users over the channel which we are having low frequencies than the channel, right. So, in order to get a proper communication between a transmitter and a receiver, we have to bifurcate frequencies among the users. Or you can say that we are having a process of multiplexing and demultiplexing over here also. After multiplexing, we are having a communicating channel consisting of different mediums, and for multiplexer we are having many to one, as we have seen in a multiplexing concept in my earlier video. So, input, we are having different inputs, a single communicating single data line will be there consisting of the single single output, and that single output becomes the input to the demultiplexer for demodulation across the communication channel and to get the required output. Here we are having different channels, okay. Channel 1, 2, 3, you can also increase channels over here. Or we can say that signals generated by each user are modulated into different carrier frequencies and then combined to a single composite signal and transported to the link for demodulation to get final analog output. So, what is happening right now? Different users are having analog input, and with the help of different individual carrier frequencies, these signals are being modulated over the channel, right. After modulation process, at the receiver side a demodulation process will be there, and carrier frequencies are being separated from the output of the channel and will be getting a required output in a form of analog, right. So, the process of modulation and demodulation is very important as far as frequency division multiplexing is concerned. In my next lecture, we will be discussing that how modulation and demodulation process is being taking place. Thank you.